Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Number of islands, Leetcode 200. This problem is a good one in the sense that many graph related problems are built upon this and it encapsulates the fundamental concepts that are crucial for understanding more complex problems. In this problem, we are given an m into n 2D binary grid which represents a map of ones which are land cells and zeros which are water cells, and we have to return the number of islands. An island is surrounded by water and is formed by connecting adjacent land cells horizontally and vertically, but not diagonally. And we may assume all four edges of the grid are all surrounded by water. Then in example 1, we can see that these ones represent the land cell and these zeros represent the water cell, which I have also drawn here. So whole of this connected land cell is one island. So that's why we will return 1 as our answer. But in example 2, we have 3 islands. One is this one, then this one, and finally this one. So because of this, there are a total of 3 islands. Note that we cannot connect diagonally. So that's why we count it as a separate island. Now in terms of solution, we have to count number of islands, which are land masses connected horizontally or vertically, but not diagonally. Therefore, we can think of land cells as nodes in a graph connected by edges if they are adjacent horizontally or vertically. This transforms the problem into a graph traversal challenge. And this is very similar to other problems we have seen in the past, like count sub-islands or maximum number of fish in a grid. To solve these problems, we can either use breadth first search or depth first search. Today we will be solving the problem with a DFS, but BFS will also work in case you want to try it out. So we will initialize a counter, answer to 0, which will hold our number of islands. Next, we will take the following steps. We will iterate through each cell of the grid to check whether it's a land cell or a water cell. If we encounter a land cell, we will perform a DFS to explore the entire connected island. Each DFS marks all reachable connected land cells to avoid recounting them. And if we encounter a water cell, we simply skip it and continue to the next cell. And once we have gone through all the cells, we will have our answer. For example, for the current grid, we start at the top left corner at cell 00. And since it's a land cell, we will initiate a DFS from here. And to efficiently explore all neighboring cells of a given cell in 4 directions, we can use a directions array as covered in the similar problems in the past. So we have 4 directions defined as -1, 0 for going up, 0, 1 for going right, 1, 0 for going down, and 0, -1 for going leftwards. This array will contain 4 directions, each represented as a pair of coordinates dx, dy, which denote the unit change in the coordinates from the current cell x, y in the specified direction. So for each cell, we can calculate the adjacent cell's position nu x, nu y as x plus dx and y plus dy respectively. Based on this, we may get some cells that are out of bounds of the matrix, and we should ignore those invalid cells. For example, for cell 00, moving up will result in row -1, which is out of bounds for the matrix. Therefore, we should ignore those invalid neighbors. So going up was invalid. Then we go to the right, and since it's a land cell, we proceed here. However, from this cell, we can potentially revisit cell 00 again. So to avoid revisiting cells in DFS, we can use a visited set. In this problem, we can employ a couple of strategies for that. One way can be that we sync the island. That is, when we are visiting that cell, we can change the cell's value from 1 to 0, effectively making it a water cell. And hence, in a way, we are syncing the island. This way, any subsequent DFS calls will see this as a water cell, so it will prevent the revisits. However, the downside of this approach is that it modifies the input grid. But if the interviewer is fine with this modification, it is a practical and efficient approach. But if they are not fine with it, then another approach that we can employ is visited matrix, where we can create a Boolean matrix of same size as input matrix, that is m into n, where m is number of rows and n is number of columns, to keep track of visited cells without altering the input grid. This is effective but requires additional space. I have covered this approach in the problems like maximum number of fish in a grid. Feel free to check out for deeper understanding. Here we will be syncing the islands. So now let's count the islands. Initially our answer was equal to 0 and we started with cell 00. So it was a land cell, we sank it and started the DFS in the 4 directions. So we went up but it was invalid. then we went right, it was a land cell, so we move there and sink that as well. Then we try to go up again, but this is again invalid. Then we go to the right, this is a water cell, so we ignore it. So we then go down, and this is a land cell, so we move here and sink it. Then again from this cell we try to go up, this is a water cell now, so we cannot go here. Then we try to go right, and that is also a water cell, so we skip it. Then we go down, this is also a water cell, and then we go towards left, and this is a land cell, so we go here and sink it. And again we try to go up from here, this is a water cell now. Then we go towards right, this is also a water cell, we go down, this is a water cell, and we go left, and this is out of bounds, so we return. So as we have explored all the directions from this cell, we return and come back to this cell, and here also we are done with all the 4 directions. So we backtrack and come to this cell and try to go towards left, but this is already visited. We backtrack and finally we come to the starting cell and we try to go down, this is the water cell, then we go towards left, and that is out of bounds. So we have sank this whole complete island, and our answer has now become 1. Then we come to this cell, this is a water cell, so we skip it. Similarly, we will skip these water cells as well. These are also now water cells, so we skip them. Then we come to this cell, this cell, this cell, all of them are water cell. So we skip them and finally come to this land cell. And since it's an unvisited land cell, we increase our answer to 2. And again try to explore remaining island in 4 directions using DFS. But before that we will sink this land cell, and then we go up, that is a water cell. Then we go right, that is also a water cell. We go down, that is also a water cell, and on the left also there is a water cell. So we have explored all the connected land cells for this island. So we continue with the cell search to find the land cells. So we come to this cell, this is a water cell, so we skip it, and similarly for these water cells as well. And finally we come to this land cell, and again we start the DFS from here. But before that we will sink this island and increase our answer to 3. And first we go up, that is a water cell. Then we go right, this is a land cell, so we sink it. So from here again we try to go up, it's a water cell. Then we go right, it's out of bounds. We go down, that is also out of bound. And when we come left, that is a water cell, so we are done with this cell. And similarly for this cell we try to go down, that's out of bounds. We come towards left, and that's a water cell. So we have explored all the 4 directions for this land cell as well. And finally we come to this cell, but this is now a water cell. So we are done with all the cells, and finally our answer will be 3. In terms of time complexity now, it will be O of m into n, where m is number of rows and n is number of columns, because each cell is processed only once, and once we process it we just sink it, right? And in terms of space complexity, it will be O of m into n in the worst case, because for the DFS either we can use a recursion stack. In that case, the depth of the recursion will be O of m into n, or we may use a stack. In that case also the space complexity will be O of m into n. We did save some space by sinking the island, but still the space complexity stays O of m into n. Now let's jump into the code part. First let's initialize our answer to 0 to keep track of the number of islands and get the dimensions of the grid with m as number of rows and n as number of columns. And now we will iterate through each cell of the grid, and if current cell is a land cell, that means we have found a new island, so we will increment our answer and perform the DFS to explore this island and sink the connected land cells of this island. And in the end, once we have gone through all the cells, we will return our answer. Now let's create directions array with directions up, down, left and right, and write our helper DFS function. We will again pass in the grid and current row and column. Now for each cell, we check if current position is out of bounds, that is r is less than 0 or c is less than 0, or r is greater than equal to number of rows, or c is greater than equal to number of columns, or it is a water cell. Then in this case we should return. If we are here, that means it is a land cell, so we visit it by sinking the cell and explore all the 4 directions by performing the DFS and sink all connected land cells. Now let's submit this code. Awesome. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.